For this assignment, the main objective is to upgrade Full Thread Plus from assignment 1 into Full Thread Plus version 2. This new version is a console-based kiosk system that uses structured data, pointers, and file input and output. Users can select field types such as RON95, RON97, and DCell, check SSPD eligibility, calculate fuel charge, and manage transaction record. The system also stores up to 5 recent transactions and save them for future use. This slide shows the main features of the program. The system uses a menu-driven interface for easy navigation. Users can select fuel types, and the system checks subsidy eligibility based on nationality and vehicle category. It automatically calculates fuel charge and enforces fuel limits. The program also stores transactions using struct, support file input and output, also searching by transaction ID or customer name, and can export receipts to a text file. This slide explains the overall program structure. The program follows a menu-driven flow and starts execution from the main function. When the program starts, it loads transaction data from a file. Users then interact with the menu to perform different operations. Finally, when the user exits the program, all transaction data is saved back into the file. This ensures data persistence between sessions. The most challenging part of this assignment was integrating structured data with file input and output. I need to redesign how transaction data is stored and accessed. Handling missing of empty file was also challenging because the program still need to run smoothly without crashing. This required careful logic to ensure program stability. In assignment 2, we were required to use struct. This was challenging because multiple related attributes such as transaction ID, customer name, fuel type, ETAs, unit price, and total cost need to be grouped together. I had to change how data was stored and accessed compared to use separate variable or parallel arrays. This required a better understanding of structured data. To solve this problem, I used a transaction struct to store all related data in one record. Each transaction is stored as a single unit in an array with a maximum of 5 records. This approach reduced complexity, improved reliability, and made the program easier to manage. Overall, using structured data made the system more organized and efficient. Thank you.
I will now explain how file input and output is implemented in our code. At program startup, we use an if stream to open transaction.txt. If the file does not exist, the program detects the error, create a new file, and continue safely without crashing. The data is read line by line and stored directly into the struct array. When the program exits, an off stream is used to write all current transaction record back into the file, ensuring data precedence. The program is divided into multiple functions, each handling a specific task. For example, there are functions for loading file, saving file, calculating fuel charge, displaying transaction, and searching record. This modular design makes the code easier to debug because error can be isolated to specific function without affecting the entire program. Pointer are used to manipulate transaction record efficiently. Instead of accessing array element directly, we use pointer traversal to move through transaction record. This approach reduces direct array indexing and demonstrates pointer usage as required by the assignment. From a coding perspective, transaction history is managed by limiting the array size to 5 records. When a new transaction is added and the array is full, the program shifts all the records forward and remove the oldest entry. This ensures that only the 5 most recent transactions are stored and displayed. Overall, this assignment strengthens our understanding of struct, pointer, file input or output, and function-based programming. The code is now more organized, reusable, and closer to real-world programming practice. That's all from me. Thank you.